Alright guys, Mr. T here with your second video for your first topic of units and measurement. This one's going to be on scientific notation. Hopefully in previous years in both maths and science you've experienced this. Now, scientific notation is just an accepted way by the scientific maths community of representing extremely large or small numbers. Okay, you might think that this is a waste of time, but really, if you're going to be writing a number that's like got, say, 25 zeros at the end, you're not going to have time to write out all 25 zeros every single time. You need a shortcut, so that's what scientific notation is, otherwise known as standard form. Okay, so any formulas or any basic rules I'm going to have in these videos are going to be outlined in blue. Okay, hopefully that's a standard I can maintain in these videos. So scientific notation has two parts. It starts off, the first thing that you'll see in something in scientific notation is a number between 1 and 10. This number can have any number of decimal places. It has to include all non-placeholder digits. So what I mean by non-placeholder digits you'll see when I do an example below. And then after that number between 1 and 10 with decimals, with non-placeholder digits, you have a power of 10. So really the form of scientific notation is going to be this: a number between 1 and 10 times by 10 to the power of something. And so from our worded rules there, you've got the n, the number is going to be between 1 and 10 inclusive, and k is going to be any number. It can be positive or negative. Okay, any whole number. It's not going to be decimals that you're going to have to deal with here. So as an example here, if I wanted to write 59605,000, let me double check that. That's 59,605,000, and I want to write that in scientific notation. Well, obviously I'm going to need to represent this with a number between 1 and 10. I can't use 59, I can't use 596, I can't use 59,605. I need to use 5. And what I meant by the non-placeholder digits is, now that I've decided that the number between 1 and 10 is going to be 5, I need to represent the remaining digits here that aren't just taking a place with decimals. So it's going to be 5.9605. It might be easier to think of to work out what non-placeholder digits are by seeing what placeholder digits are. These are these 3 zeros here. These don't give any other information except to tell you that it's another times by 1,000 there. So they're just holding their place. They're not giving more information to this 59605. We can give the information there by the power of 10. Okay, so what I've done, I've gotten that 59605 at the start. I've converted it to a number between 1 and 10. I've kept all of the digits that are non-placeholders that actually mean something, and now I need to give it the power of 10. Now you may have had practice, you may have remembered how to do this, but all you need to do is see how many times the decimal place jumped. So, where do I have the decimal place now? It is here on the original number. How many times did that have to jump? 1, 2, 3, 4, 5, 6, 7 times. So, this is going to be 5.9605 times 10 to the power of 7. Okay, the power of the 10 is really telling you how many times this decimal point needs to jump in the positive direction, so to the right, how many times it needs to jump to accurately represent the original number. Okay, so just double checking that the decimal place is there, 1, 2, 3, 4, 5, 6, 7, 10 to the power of 7. Now it goes it goes into negative powers of 10 when you are going back the other way for extremely small numbers. So that's a big number. So you're going to have a positive power of 10. Here, it's going to be a negative power of 10. So you'll see here, there's a whole bunch of zeros that are just holding places. They're not giving any information. The only information is here. How am I going to represent this 59605 here? Well, as before, it needs to be between 1 and 10, so I'm going to use 5.9605. Notice here, that 0 I'm not calling a placeholder, because it's actually the value of that place there. Alright, this is just telling you how many thousand times it's been divided by. Alright, there is a number following the 0, so the 0 is important. So this time, I need to work out how many times, got an email, I need to work out how many times the decimal place has jumped in the left direction. So if I look here, the decimal place between the 5 and the 9, so the decimal place used to be there, is now there. How many times did it jump to get to where it is now? So it went 1, 2, 3, 4, 5, 6, 7. So it actually jumped to the left. It needs to jump to the left from this situation. It needs to jump to the left 1, 2, 3, 4, 5, 6, 7 times. So the power is to the negative 7 this time, because it jumped to the left hand side. It got smaller. So once again, the decimal place we're saying is now here between 5 and the 9, but to get to the original number where the decimal point was 7 places, 1, 2, 3, 4, 5, 6, 7 places to the left, we had to jump 7 times, so you're going to times it by power of negative 7. Alright, which is the same as dividing the number by so 5.9605 divided by 10 to the 7. One, 2, 3, 4, 5, 6, 7. The same thing. Okay, so hopefully that video helps you out with your scientific notation, how you do the direction jumping. Okay, if you go to the left, that means it's a negative power of 10. If you jump to the right, then it's a positive power of 10. And just make sure that you're using it in the right form, and the example should help you with converting back and forth as well. So that's that second video. I'll see you in the next one.